This week on the Computer Chronicles, how to program. We'll show you how to create the simplest kind of program, a macro, and we'll show you a software package that teaches you the fundamentals of big-time programming. We'll look at writing software for the internet with Macromedia's Flash, and a programming language even adults can master, RCX from Lego Mindstorms. Plus a visit to the real world of heavy-duty software code as we take you inside the programming team at Electronic Arts. And my pick of the week, an incredible new piece of software for audiophiles. It's all coming up next on the Computer Chronicles.
The Computer Chronicles is brought to you by BigStar.com, with thousands of videos and DVDs for the whole family. Additional support by TechWay for up-to-the-minute technology news. And by TVA, Television Associates, bridging the worlds of computers and video with DVD authoring and MPEG encoding services.
Hi, and welcome to the Computer Chronicles. I'm Stuart Chaffee. In the early days of personal computers, 15 or 20 years ago, you had to know how to program to get your computer to do anything. When you bought your PC, it came with almost no software, but it did probably come with the basic programming language. And then it was up to you to write a program so you could do something with your PC. Fortunately, those days are over, and you don't have to program anything, but you may want to. It can be useful, and it can be fun. In fact, you probably don't know it, but many of your desktop applications have programming capabilities built into them. They're called macro engines. So we thought we'd start our look at how to program with the easiest example, how to create a macro. And at Microsoft, most people don't know it, you've got all kinds of programming capability hidden inside your Office applications, right?
Right, it's actually a poorly kept secret because it turns out millions of developers actually use the macros to write solutions. But also end users should know that behind every Office application is an environment where they can actually create.
And somebody once told me, in fact, macros are the most common programming language in terms of people actually do stuff.
Absolutely, absolutely.
All right, let's talk about some examples here. I want to automate some stuff, for example, in a spreadsheet. Right. Show me an example of how I could write a program using one of your macros.
Absolutely. Well, let's start with Excel 2000, Microsoft Excel 2000 here, and we'll talk about automating just an arduous task of filling out an expense
report. You do the same junk over and over and over again, so why not write a program to do that?
Absolutely, and actually we're going to show you how easy it is. You don't even have to write the program.
Okay.
We're going to go ahead and record a macro using macro recording. And we go to Tools, Macros, and we'll go into Tools, Macros, and we're going to record a new macro.
And that means watch me do stuff, and the next time I just want to press a button and you do it.
Absolutely, and we're going to call this airport because we're going to start filling out our expense report and going to the airport.
Okay, so you always go to the airport on a business trip, so why do the same stuff over and over again?
Absolutely, and there's actually a variety of things I wanted to automate. So right now, it is recording everything I'm doing.
Okay.
So I'll put in my employee ID number, my name I can remember.
Okay.
And now
but this is stuff you shouldn't necessarily have to do every single time you fill in an expense report.
Especially since I never can remember my call center number.
All right.
And we'll go ahead in the description, and we'll just start it out with travel to airport.
Okay.
Okay. And mileage, I know that's 17 miles. Okay. So that's just a very
simple. You haven't
simple.
moved, so that's always going to be the same.
Exactly. So we've got 17 miles, and Excel can calculate how much.
Got it.
Whopping 5.
So all that stuff is what you would do to say, hey, give me the money for the trip to the airport.
That's correct. So now we can actually go ahead and just stop our recording. Mm-hmm. And we're ready, and now what I'll do is I'll clear it out here secretly.
All right.
And as if we were coming to it again.
Now we've written the macro. Next time we go to do the same expense report, what do I do?
Well, we just go into Tools, Macro, Macros, and there's our airport macro. And we'll go ahead and run that, and just in a moment we fill that out. Absolutely.
Now, I didn't have to know anything, right? I just said keep track of what I'm doing and then do it the next time.
Easier than programming a VCR. You had to click the record button.
You don't have to know about programming.
Not in this case. But
all right. Next example, can I actually add functionality that you guys didn't put in it because it's appropriate for what I want to do with the program?
Absolutely. We can't think of everything when we create a piece of software, so it's really nice to give you the tools to create your own features.
Like what?
So we'll go into the Visual Basic editor because Visual Basic for applications.
So underlying all this is you're really writing this stuff in Visual Basic.
Absolutely. Okay. And so each of the Office applications has this behind it. We're also giving this licensing this to third parties like Visio, Corel, Autodesk, all have the same exact programming environment. So let's take a look. That's the macro we just recorded.
Oh, so that's the underlying code in BASIC that was just doing what we were doing.
Absolutely. You can even see if I...
And I didn't have to know from all this stuff. I just said, do it.
record. But let's say you
But I could,
wanted
if I
to.
knew my stuff, I could go in there and edit that and modify that?
Absolutely. Let's say you moved closer to the airport and you wanted to become 17.
Okay.
You've just changed
All right,
that.
so let's go to the example I asked you. How do I add some feature to the spreadsheet?
Absolutely. Let's talk about how we could get something like a calendar. I can never remember the date. I know that I traveled Monday,
So
but
you want to look at a calendar and say, what date was it?
absolutely. And I want to be able to build that in Excel. So we're going to go and do that, and I'm going to write one line of code to do it. The first thing we do is just add a form and use one of these ActiveX controls. They're in Office, and they're available to you, and you can build your calendar control right on the form. That's it.
Okay.
And we're ready to actually write our one line of code. And that one line of code will be go to the active cell in Excel and change the value. You can see IntelliSense in VBA is helping me write this code.
Right. So this I would have to figure out how to do, though, right?
Absolutely.
This is not, okay.
This is not the simplest thing in the world,
Right.
but actually people use
Not too
macro
hard.
recording to do it.
So what happens?
So a calendar one.value. So let's just go right to our spreadsheet now. And now when I double click on the date field, you'll see that calendar
just what I
has
wanted to
popped
do.
up. And as I click around, I'm
Cool.
selecting dates. New feature we just added.
Two baby examples. I know there's all kinds of other things you could do we don't have time for, but hey, explore macros inside your Office applications, right?
Absolutely.
Thank you very much.
Sure.
All right, well, if you've had some fun creating a few macros and then you want to get really serious about writing your own applications, you can do that. There's a software program out now called Code Warrior Discover Programming for Windows, and it can turn even you into a programmer. I guess that's the theory, right? I mean, you can learn to do this complicated stuff.
Exactly. Basically what we're looking for, the Discover Programming product, is it's for a novice programmer, someone who's never programmed before, and it actually walks you through how to
So
program.
I could learn to program in C, C++, Java, or Pascal on this, right?
Yes.
Which sounds like really a lot to learn,
Right.
but I can do it.
Yes, you can. And the nice thing is it's all in the same environment. So you would have to learn the languages,
Yeah.
but the environment for each language would be the same.
All right, let me give you an example. I'm sort of starting out here, and I say, well, I want to learn just to do basic things. I'm going to write a little game, for example. You know, the game of Reversity. That's not too complicated. How would I mean, that's one of your projects, as I understand it, in there. I can pull it up and actually kind of look at what the code was like as part of my learning process?
Yes.
All right, how do I do that?
Okay, basically we have the Reversity application pretty much already set up.
All right, so what's in that window?
Right here, now this is the actual Code Warrior environment with these right here.
So there's the source code, there's the libraries you're accessing to do that stuff?
These are the libraries right here, the source code, and everything's drag and drop if you want to drag, you know,
Okay.
certain files somewhere and things like that.
And can I see what the code would actually look like?
Actually, if you wanted to actually look at the code, you can
drill down there?
Yep, and
Okay, there it is.
Double click on that, and you know we have other options if you're looking for. You can.
All right, and if I wanted to run the code and see what's happening, or
If you
debug?
want to run, yep, you just come up here to the run and debug, and you run the actual code like this, and now it's actually compiling,
Right.
and it will actually.
Now, as you say, I mean, eventually I'm going to have to learn that language on the left there and what the commands are. But this is part of the process, sort of looking at somebody else's code and figuring out how they did these things.
Exactly. Yeah. I mean, that's one of the major things. Now here we just popped up. You know, the debugger window just popped up, and if you
Okay.
wanted to actually look at, you know, if you wanted to step through your code, you can just step through like this,
Right.
and it will stop on
Got it.
there. And if you want to actually show what the reverse game is,
So actually running the program now, hey, that's what would have happened if we were playing the game.
exactly.
All right. Now, looks kind of simple, but there's a lot of complicated stuff in there. If I'm going to learn C++, it's going to take some learning. How do I now use your software to say, teach me how to do this kind of stuff?
Well, what we have with the Code Warrior software is we have a website that comes with the software.
Okay.
And all you have to do is when you load up the software, it's on the documentation CD. Basically, this is the documentation
So
CD.
this is sort of a self-running tutorial, and it's just me and the computer, and it'll teach me this stuff.
Exactly. And as you can see, there's a welcome, there's hints for using the site, getting started, all different types
All right, so
of...
give me an example of where I said getting started is
Okay.
where I'm at, and I want to get an idea, how do I begin this process of learning to code in C++?
You just double-click on the Getting Started part, and then if you want to actually look at the Code Warrior IDE,
All right, so you got a tutorial set
Yep.
up there, so let's take a look at that one.
you just click on that, and it will give you a guided tour through the IDE.
All right, now can I sort of work on little baby projects, and it'll guide me through that? Is that how I would do this?
Yes, that's exactly how you do it. You can work on baby projects, and we actually have examples for each language, C, C++,
Okay, I mean
Java,
like the
and Pascal.
Reversity thing we looked at?
Exactly, that's right on the documentation CD
So
itself.
I could load in that program and say, well, what would happen if I changed it here and did this and made it green instead of blue, or made it this big a board instead of that big a board, and mess around with that?
Exactly.
I can't blow it up, can I? I mean, I can always go back to
Well,
where I started.
you might run into a few errors here and there,
Yeah.
but
As a practical matter, I mean, it still seems kind of complicated. I mean, normal guy, you know, relatively smart, I'm playing on a computer, I want to learn programming. How long would it take me to get in here and figure out to do something like the reverse game?
Well, I mean, it will take some time. You need to learn the languages, but
Right.
like I've said before, you know, the nice thing is the IDE will be the same on no matter what
The
language.
IDE stands for?
Integrated Development Environment.
All right, so you have sort of one platform for doing all this regardless of the language, is that it?
Exactly. You know, an IDE would be similar to in Word when you want to create a document. The IDE would be
Okay.
the word for actually creating a program and things
All right.
like that.
So again, a normal person could get in here and actually learn with the software and end up figuring out how to write something.
Yes.
All right, what does this thing cost to buy this?
This is $79.
Oh, that's not bad.
Yes.
And all 4 languages are in there.
All 4 languages, yes, C, C++, Java, and Pascal.
Thank you very much.
Thank you.
All right, well, the cutting edge for professional programmers is usually computer games. There's nothing like a game to push software code to the limit in terms of graphics, speed, interface, etc. So we thought we'd give you a glimpse into the crazy world of big-time programming with a visit to the inner sanctum of the Electronic Arts programming team.
An airplane soars, the propeller spins, and bullets spew from wing-mounted guns. The action in James World War II fighters from Electronic Arts may look real, but it is not. It's just a mathematical model that responds to directions placed in the program's code. Of course, code is not the only factor in making a successful game.
When we start the process, we're thinking about how to make it as cool as possible, to make it as real, to make it as visually stunning as possible. In the process of implementing that, then we have to figure out how to do that and what are our limits, what's our target hardware, how fast can it go, how many polygons can we use.
Any software game calls for teamwork between programmer and artist, but programmers do have ways to simplify and accelerate action, an important advantage for smooth gameplay.
We're always trying to optimize our code so that it runs faster on the same existing machine. Basically, the more efficient that our code is, the better the frame rate of the game will be. So it'll update the screen more times per second.
The game's opening sequence features a sample battle between German tanks and Allied warplanes. In an early version, the player's viewpoint, as seen through a virtual camera, is static. In the later version, camera moves were added to create drama and suspense. Here's how it was done.
What you see is at time 0, the pitch of the camera will be rotated from 6.09 radians to 6.15 radians over 6 seconds. So that'll give us sort of this pitching effect on the camera, which sort of adds more of a dramatic flair to it. Some other big things that happen later on, I will change the camera to an outside view of the hangar at 10 seconds. So it adds a lot more of a movie feel to it. You'll get sort of a prime shot of the P-47s coming in for their bombing run right now. This is my favorite part right here. So every camera movement that you see is scripted in that file that I showed you before.
To achieve the greatest realism, game designers took actual aircraft models and copied every detail they could, from the fuselage to the cockpit gauges. And to manipulate so many parts in sequence, programmers grouped them together by hierarchy.
When we're thinking about the hierarchy of the shape of the plane, and let's say that we're writing the part of the game that involves the bullets hitting the plane. So we need to detect exactly where the bullets are hitting. We do that. We model exactly where on the plane the bullets hit, and we affect the flight model that way. So by breaking the shape into a hierarchy, we can say, well, this bullet hit the wing root here, and therefore it'll affect the flight model in this way.
James World War II Fighters was written in C++, but programmers point out that no one language is specific to games. The code uses object-oriented programming or reusable modules to lessen the number of repetitive tasks.
Let's say that you're trying to model, let's say the bullets. So you're firing a gun, and we're creating thousands of bullets every minute, depending on the rate of the fire of the gun. We don't want to repeat code over and over 100 times for creating the sound effect for it. So we create one module that says create a sound for one bullet. And if that works, if we debug it, and if that piece of code is stable, then we'll have no problem calling it 1,000 times.
Game designers may spend most of their time creating efficient code and realistic graphics, but they still need to keep one primary goal in mind.
Well, our the holy grail is it has to be fun. I mean, if it's not fun, nobody's going to play it. And it can be gorgeous, it can be amazing, but if it's not fun to play, we're not going to have people buying it and telling other people to buy it. So we really have to make sure that that's there. And that's an elusive thing the harder you chase it.
For the Computer Chronicles, I'm Sarah O'Brien.
These days, programming is as much about websites as desktop applications. The programming challenges in the internet era are about things like adding cool graphics, animations, sounds, and activity to your website. And that requires working in a different kind of programming language. One of the most interesting ones is Macromedia's Flash. And Kevin, you've got a Flash-enabled website up there right now. We're seeing this is doing all kinds of stuff. It's not just sitting there.
Yes, that's right. Yeah, designers can create content for their websites with interactivity and changing graphics.
Sounds are going on, and if you click, what happens on one of these things?
You click, it goes to another area of the site. You can see it goes to more Flash content, and it loads in. You can see buttons appearing here and rollovers. When you click, it changes the image.
All right. How complicated is it using Flash to create stuff like that?
It's not complicated at all. It really enables designers to create this content rather than pure engineers of the past. So
all right, so this is sort of the authoring tool?
Yes, this is the Flash authoring tool.
Okay, where do I begin?
You create objects on the scene here, and you can do things like dragging a fish out onto the stage.
This sort of timeline editing in a way is what we're doing?
Exactly, yeah.
Okay.
The way you program in Flash is there's a timeline that indicates what things happen over time.
All right,
you can
okay.
attach
So we
actions
start with fish on right side of frame.
Exactly, and say you wanted the fish to swim on the other side of the frame. We can just create another keyframe here. Keyframes indicate activity or change in the timeline. And I can drag the fish over to the other side of the screen.
So at that point, you want the fish to be on the other side.
Exactly.
And you've now created an animation?
That's right. Yeah, and if I were to play this, the fish right now stays on one side, and then when it gets to the last keyframe, it jumps.
Okay, not realistic.
No.
How do we make it real?
What we do to make it real is something called tweening. And you can instruct the animation to actually move itself across time.
So automatically create those in-between frames that'll make the animation look real.
That's right. That's where the word tweening came from.
Got it.
In-betweening. And now when I play the animation, you can see the fish.
Okay.
It goes across
So
the
that
screen.
motion was sort of automatically built into that fish object? You didn't have to figure that all out?
Exactly, yeah. It started basically having little animations within the fish object.
All right, so what else could we do with that?
Well, another example is you can add buttons. So if I wanted to put that fish, say, in a website I was creating in a portfolio, I could attach buttons that show and hide these animations.
All right, now lots of times, you know, when we hover over a button, things happen. Can you do that in Flash?
Oh, absolutely. Yeah, you can select these buttons and edit them, and you can change what happens in each different state of a button. So this is a way you can program a button visually.
Okay, so your cursor's over the button, something happens. You click down on it, something happens.
Exactly.
You select it. Okay.
Exactly. So for instance, if I'd like something to happen when my mouse is over the button, I could change its color. So for example, instead of green, maybe I'd like to make it like a blue.
Okay, so the over condition would be blue now.
Yes, and up is green and over is blue.
Got it.
And we can see this in the main view here if we just say enable our buttons. And now we can see when I roll over these buttons,
turns blue.
They're now highlighting.
All of them, too.
Exactly.
So that same language automatically got exported to each of those buttons.
Yes, yes.
So
It's like code reuse.
You don't have to write the same code over and over again. Got
exactly, yeah, it's shared.
All right, now suppose we wanted something to happen when we, say, clicked on that or we moved over the button.
That's very easy. You can program these buttons by attaching actions to them. Now, this is how you do the programming of buttons within Flash. And you can choose different commands to attach to a button, like go to a frame, play or stop an animation. I'll load a movie here. I'll load that fish that we were just seeing before.
All right, so the point is here, when I press on the button, I want the fish to swim across the screen?
Exactly. And I'll also attach, say, a logo here, too.
Okay. This is kind of intuitive, right? I mean, this is not sitting writing some arcane commands.
Exactly. It lets you program visually in a way that many artists can do. I think that there's a shift happening where lots of these designs can be created by artists rather than traditional programmers.
All right, so where are we now?
Now when you run test movie, you can see the buttons that are
blue.
Exactly. And when you press
on it,
the fish comes swinging out. And also a logo plays a little logo. So that's basically programming in Flash.
Yeah, so I mean a normal person without a great deal of training or background can use Flash to do this kind of stuff.
Exactly.
Now, where do you get the authoring tool if you want to play with this stuff?
You can download it from macromedia.com.
Okay.
And it's a 30-day free trial version.
If
you like it, then you can buy it.
Great, Kevin, thank you very much.
Thank you.
Well, programming may be difficult for some people, but it can be fun for everyone. So to show you the playful side of computer programming, We're going to look finally at a new programming language called Xcode language. It's what you use to write programs for the new Lego Mindstorms robots. You've got the great job, Chris, of playing with these things. And let's try to explain what we're talking about here to people. In the old days, if I would build a Lego, I put a motor in it, it just runs, right? There's no intelligence.
That's right. It was easy to make really simple actions like this that I've added here.
Go, but then it would
go off the
crash.
edge. Okay.
All right, now I want to write a program that says to this thing, if you see an edge coming, stop.
Right.
How do I do that using RCX?
So if I switch to a smarter program here, what I've done is added, I have some sensors built into this.
Let's explain what you're talking about there. This is one of your sensors, right? And that's
right.
a button, and that gets pressed, and that sends a message. If I would hook this up, sends a message to the computer.
Exactly.
And those arms, when they fall, press that button.
That's right.
Okay.
So what this program does is notices that it reaches the edge and does something about it.
When sensor gets hit, stop.
Right.
Okay.
Let's watch it go.
Just in case. Hey, all right.
Okay.
Now, we're talking about programming. How did you write that in the Xcode language?
Well, here's that program on the screen. And you notice that the Xcode programming environment is very different from your standard textual programming
So each one of
language.
these kind of jigsaw puzzle pieces is an action.
That's right. These are little commands, and you string them together to form a program.
Right, which is what a program is, of
That's
course.
right. So this program here says first set the speed of the motors,
Right.
then set the direction of the motors, and
Turn it
finally
on.
turn them on. So start moving the vehicle
So
forward.
we want to say when sensor goes off, stop motor, right?
That's right. So then I've added these two blue blocks here, where they're called touch sensor watchers.
Okay.
One for each arm on the invention.
Got it. So you got two sensors on here, and
Right.
you want to say if either of those sensors go off, stop.
That's right. So what I added at the end here was a command that told the motors to turn off.
Okay.
So if either the touch sensor is pressed, I have the motors turn off.
Okay. So can you change to that program in there and try this?
Well, we just ran it, so
that's right. We actually
what
did
caused
that
it to
one, yeah.
stop.
Okay,
But
fair enough.
maybe we want to do something more interesting, like
Yeah.
have it back up.
Okay, so now we want to rewrite the program and say, if you see an edge, stop, and then start to go backwards.
Yeah.
How do you write that?
Okay, so on the left here is a menu of all kinds of different commands that I can use. These affect the motors. I have sensor watchers here that let me detect light and touch, and then I have ways of repeating commands and branching on different
Now,
commands.
Chris, this looks kind of baby-like, but these are the fundamental concepts of programming, right?
That's right. It has looping, branching, iteration,
All the same stuff,
conditionals.
it's just in a simple visual way to deal with it.
Right.
All right, so let's write that program.
So I scroll down here to the reverse direction command and add that to both touch sensor washers, and then scroll up to the command that's going to turn the motors back on again.
Okay,
now
change
that
the
we've-
direction of the motor, turn the motor back on if either sensor
Exactly.
gets a message. So let's see what happens now.
So I can put this program in by clicking download.
So you got a little IR port here that sends the new code into the computer.
That's right. We didn't want to have wires attached to our invention so they can now roam around freely. So we send it by infrared.
Okay.
Just take a second here for the program to go in. Okay.
I hear a little beep, so maybe it's happy. So now it should see the edge, stop, and go backwards.
Let's try it.
Stop. All right. We wrote a program.
Yep.
Last one, there's something a little more complicated in which you have an avoidance program in which it says if you see an edge, just try another path. I mean, don't go that way, right?
Right. Let me just load that in real quick. This gives you an idea of some of the potentially pretty sophisticated things you can do with Xcode. And you'll notice that on the screen here, what you see is a longer stack of commands under each of these touch sensor watchers.
Right.
Now, I don't want to go into detail about what each of those stacks
But
do.
you can write a long program here to tell us to do a lot. I mean, I've seen some of these things that are shooting baskets and dealing cards.
That's
and
right.
all kinds of things.
That's right. So I'm just
All
going
right,
to
so see if we can run that
I'm
program.
going to go ahead and switch directly to that instead of downloading, but it's
so
in
now
memory
explain
here.
what it's been told to do now.
Okay, so what this program's going to do is when it detects an edge, back up and then change direction and then go
And
forward
look for
again.
another path that might not have an edge?
That's right.
Okay, so let's see what happens. That work?
There, it's turning.
Okay, okay. And we can see either one falls down and that sets that thing off.
Right.
That is cool. And we might point out that Lego sounds like kids, but it's mostly grown-ups that are playing with this thing, right?
Oh, that's right. I guess about 50% of the users now are adults.
Chris, thank you very much. All right, that's our look at computer programming. I'll be back in just a moment with my pick of the week. Now for my pick of the week. Computers are increasingly being used as music playback devices, even audio recording devices. But most PCs come with rather primitive audio control systems. Now, however, Samsung has come out with an incredible package called Jet Audio Plus, which can instantly turn your PC into a powerful sound studio. Jet Audio includes a virtual rack of 7 robust audio components. First of all, a 20-band spectrum analyzer, including special effects such as reverb, flange, pitch adjustment, and room tone. It includes a sound mixer for both playback and record. It includes a karaoke-enabled MIDI player with real-time control over key and tempo. It has a fully programmable CD player, which also includes automatic access to the Internet's compact disc database for adding alpha information to your player. It also includes a specialized digital audio player which can handle MP3, MPEG, WAV, and real audio files. And it comes with a very high-quality digital video player that supports all major file formats and runs very crisply at close to 30 frames per second. But there's more. Jet Audio Plus also comes with the Jet Radio module. It's a handy internet radio tuner that lets you tune into any one of more than 1,000 radio stations at the click of a button. You can also organize your internet radio stations by format. And it has this handy pop-up remote control and a remote equalizer that can stay in your desktop even when the main player is minimized or closed. This is one heck of a little package, and I haven't mentioned half of the things you can do with it. It's Jet Audio Plus from Samsung, and it costs only $49. That's it for this edition of the Chronicles. Thanks for joining us. More of the latest in hardware, software, and the Internet next week. I hope we'll see you here next time.
The Computer Chronicles is brought to you by BigStar.com, with thousands of videos and DVDs for the whole family. Additional support by TechWeb for up-to-the-minute technology news. And by TV